All right, let's dive into some AI research today.
Sounds good.
We're looking at a paper from Meta AI. It's
Oh.
called MarDini, Masked Autoregressive Diffusion for Video Generation at Scale.
This one is exciting for anyone in AIGC.
Yeah.
Because it's really hard to create high-quality videos with AI.
Yeah, we've seen amazing AI-generated images, but video.
Exactly. Video is way more complex.
Right.
It's visuals, it's motion over time.
Okay, so who are the authors of this paper?
Well, the lead author is Hao-Liu.
No.
He was at Meta AI, but now he's at Cost.
Okay.
And he worked with a team of really brilliant people.
Yeah.
Shikun Liu, Zijin Zhu, and Jürgen Schmidberger.
Wow, a dream team.
Yeah, really great.
They're tackling a big problem, right?
Huge problem, yeah.
AI video generation has been really slow and expensive.
And it's just difficult to get right, especially for longer videos.
Especially for longer videos.
Yeah.
So how does this MarDini approach, how does it change things?
So MarDini throws out the old way of doing things and introduces a new two-stage process.
Okay.
Much more efficient.
Okay.
The first stage uses this thing called masked auto-regression, or MAR, to create kind of like a rough draft of the video.
Okay.
So it's figuring out the story in motion at low resolution.
Kind of like a storyboard.
Exactly, like a storyboard.
Okay.
And this is handled by what they call the planning model.
Okay.
Then there's a separate generation model that takes this rough draft and uses diffusion to create high-resolution video frames.
So it's like sketching out the big picture first.
Exactly.
Then going in and adding details.
Precisely.
Okay, so for those of us who aren't super familiar with diffusion models, can you give us a super quick ELI 5 on that?
Okay, so imagine you have a perfectly clear picture,
Okay.
and you slowly add noise to it until it becomes completely blurry.
No.
A diffusion model works in reverse.
Okay.
It takes that blurry image and gradually removes the noise until you get back to the original clear picture. And in the case of video, it's learning to create those clear frames from a blurry, noisy starting point guided by the plan.
Okay, that's fantastic.
Yeah.
So by splitting the task and using this diffusion method, MarDini is able to overcome some of those limitations of previous video generation models.
That's exactly right.
Okay, so how did they evaluate it?
So they evaluated MarDini on two main tasks.
Okay.
They used video interpolation and image-to-video generation.
Okay.
And they used standard benchmarks, VidimBench and VBench.
These are well-established benchmarks, so we can really compare it to other approaches.
Exactly.
What were the standout results?
So for video interpolation, MarDini completely blew the competition out of the water.
Really?
Set a new state of the art.
Wow.
It produced incredibly smooth and natural transitions between frames, even with limited information.
Wow, that's amazing.
And it even performed very well on image-to-video generation.
Okay.
But it didn't reach the very top of the leaderboard for VBench. However, you have to keep in mind that it wasn't specifically fine-tuned for image-to-video generation,
Right.
unlike some of the other models that it was compared against.
So the fact that it even competed is pretty impressive.
Yeah, exactly. It's a big accomplishment.
And this speaks to the power and flexibility of the approach, right?
Absolutely. Absolutely.
Okay, so can you talk about the ablation studies?
Sure.
What are they and what did they find?
So an ablation study is a way of figuring out which parts of a model are really essential.
Okay.
And you do that by removing certain components and seeing how it impacts performance.
Makes sense.
It's like taking apart a car engine and seeing which parts are absolutely necessary to make it run.
I like that.
So what they found was that both the planning stage, using MAR, and the diffusion-based generation stage were really important for achieving good results.
Okay.
Removing either component really decreased the quality of the generated videos.
Okay, so you need both.
You need both.
They also looked at the asymmetric design.
Yes, they found that the asymmetric design was crucial for allowing MarDini to handle higher resolution videos and longer sequences.
So that's the planning model, working at a lower resolution.
Yes.
To save computational power.
Exactly.
For the generation model working on those higher resolution frames.
Exactly.
So without this, they wouldn't be able to handle more complex tasks.
It would have been too computationally demanding.
Okay.
And they also found that the planning signal from the MAR stage was essential for maintaining long-term coherence.
Okay, so it's not just about generating, visually appealing frames.
Yeah, that makes sense, right?
It has to tell a story. It has to flow.
Yeah, exactly.
Okay, so MarDini is clearly a big step forward
It is.
for AI video generation, but where do we go from here?
So there are some really exciting avenues for future research.
Okay.
One area they're really keen on exploring is how to incorporate text prompts into the process.
So instead of having to feed it visual data,
Yeah, exactly.
you could just tell it what you want,
You could just tell it.
and it would create the video for you.
That's right.
That would be incredible.
And they're also looking into how to handle even longer video sequences.
So right now it's focused on shorter clips, but you're saying eventually it could create like a full movie.
Yeah, imagine that.
That's mind-blowing.
And lastly, they're interested in how to incorporate different types of data,
Okay.
like audio cues, into the generation process.
So it would be more immersive and engaging.
Exactly.
That's really interesting.
Really cool stuff.
It's amazing to see how quickly this field is progressing.
It is. It's amazing.
But for now, let's take a closer look at some of the more technical details of MarDini.
Okay, sounds good.
Let's talk about the data representation and notation they used.
Awesome, yeah.
This is where we can really appreciate how clever their approach is.
It is. It's very clever. To really understand how MarDini works, we need to look at how it handles the video data.
Okay, let's unpack that.
Yeah.
Because data representation can get a little technical sometimes.
It can, but it's really a key part of what makes MarDini so efficient.
Okay.
And they use this clever trick called a variational autoencoder, or VAE.
VAE.
Yeah.
Okay, can you refresh my memory on that?
Sure. So imagine you have a huge video file on your computer.
Yeah.
Takes up a ton of space.
Okay.
A VAE is like this super smart compression algorithm
Okay.
that can shrink the file down without losing important information.
So it's like zipping a file.
Yeah, it's like zipping a file, but way more sophisticated.
A supercharged zip file.
Exactly.
Okay, so how does MarDini use this compressed data?
So it breaks the compressed video down into these smaller chunks called patches.
Patches.
Yeah, and remember that asymmetric design?
Yeah.
So the planning model works with the low-resolution patches.
So it's focusing on the bigger picture, the motion and flow.
Exactly, without getting bogged down in the details. Like an artist sketching out a painting before using the fine brushes.
I like that.
And then the generation model works with the high-resolution patches to create those final video frames.
So the planning model sets the stage, and the generation model brings in the actors.
That's a great way to put it, yeah.
Okay, and both models have some really interesting architectural features.
They do.
You mentioned something called spatio-temporal attention.
Yes, so this basically allows the model to consider the spatial and temporal relationships between video frames.
Okay, can you break that down for me?
Yeah, so spatial relationships are about where things are in a given frame,
Okay.
like the position of objects, their shapes,
Okay.
and temporal relationships are about how those things change over time.
So movement, speed, the flow of the action.
Exactly.
Okay, so spatio-temporal attention means the model is looking at both where things are and how they're moving.
Yes,
They're getting the full
part of
picture,
this picture. Yeah,
not just a snapshot.
exactly.
And the paper also mentioned something called temporal attention.
Right, so they actually use both.
Okay.
Spatio-temporal attention is used in the planning model. But they found that using only temporal attention in the generation model actually worked best.
Okay, and why is that?
Well, it makes sense when you think about it.
Okay.
The generation model is already working with high-resolution patches.
Okay.
So it's mostly concerned with making sure those frames flow smoothly over time.
So each model is using the type of attention that's most relevant for its task.
Exactly.
Okay, that makes sense.
It's all that optimization.
Okay. And you mentioned that they trained MarDini using a progressive approach.
Yes. So instead of throwing everything at the model at once,
Yeah.
they gradually increase the complexity of the tasks as the model learned.
Okay, like starting with the basics.
Yeah, like training an athlete.
Okay.
You start with simple exercises.
Okay.
And then you increase the intensity as they get stronger.
Okay.
And they actually started by training the planning and generation models separately.
Oh, so individually first.
Separately.
And then they brought them together.
Then they brought them together.
Good.
Once those models had a solid foundation, they were trained together on a simple video interpolation task.
Okay.
And then in the final stage of training,
Yeah.
they gradually reduced the amount of information the model was given.
Okay, so they were making it work hard.
Making it work harder, yeah.
So that it would become more independent and creative.
Exactly.
And learn to generate more frames on its own.
Exactly.
Wow. Okay, so it's not just about the architecture.
It's about the whole training process.
It's about nurturing its development
exactly.
over time.
Over time.
And you also mentioned they increased the resolution and duration of the videos as the training progressed.
Yes. So they started with smaller, simpler videos videos
Okay.
and gradually move to larger, more complex ones.
Okay, so kind of like learning to draw basic shapes.
Yeah, like learning to draw basic shapes before painting a masterpiece.
I see.
And by doing this, they ensured that the model could handle the complexity of real-world videos.
Okay, so it's really a holistic approach to training.
It really is.
It's about the model, the data, the training method, and how they all fit together.
All the pieces have to fit together.
And that's what allows MarDini to perform so well.
That's right.
It's a testament to their deep understanding of AI
Yeah,
and their ability to push the boundaries of what's possible.
exactly.
Okay, so we've talked a lot about the technical details, but let's step back for a moment and talk about the bigger picture.
Yeah, let's talk about applications.
Yeah, because ultimately it's not just about the technology. It's about how we can use it to create something meaningful.
It's about the impact.
So we talked about how MarDini works, but what about the real-world applications of all this?
Well, some of these are like straight out of science fiction.
Okay, let's hear it.
One that really stood out to me is zero-shot 3D view synthesis.
Okay, that sounds impressive, but break it down for me.
Basically, it means that MarDini can generate different viewpoints of a scene,
Oh,
even though it's only ever seen 2D videos.
so it's like it can imagine what the scene would look like from a different angle.
Exactly, like it has spatial awareness.
Wow.
This could revolutionize VR and AR.
Yeah, more immersive and realistic experiences.
And think about the possibilities for 3D modeling and animation.
It's like giving creators a whole new set of tools.
Exactly.
Okay, what other applications are there?
Well, we talked about video expansion.
Right, making those short clips longer.
But imagine if we could use that to transform short-form content like those viral clips we see all the time.
So the short clips could become like mini movies.
Exactly, and not just by adding extra frames.
Right, it would have to maintain the style and coherence of the original.
Precisely, like taking a snippet of a song and having MarDini compose the rest of the symphony.
Okay, this is getting really interesting.
Another thing they experimented with is hierarchical autoregressive generation.
Hierarchical autoregressive generation.
Yeah, it's a mouthful, but it's really cool.
Okay, I'm listening.
It allows MarDini to generate frames that go beyond what it was trained on.
Okay.
So they took a 4-frame sequence and used this technique to turn it into a 128-frame slow-motion video.
Wait, so it took a short clip and turned it into slow motion.
Yeah, and the results were amazing.
Wow, think about what that could mean for sports analysis or scientific research.
Absolutely, we could slow down those incredible moments and see every detail.
That's incredible.
Yeah, it really pushes the boundaries.
But there have to be some limitations, right?
Of course, no technology is perfect.
Right.
One area for improvement is text prompts.
Okay.
Right now, MarDini needs visual data.
But imagine if you could just tell it what you wanted and it would create it.
That's the dream, and it's something they're working on. They're
Yeah.
also exploring ways to make it more efficient.
To handle those longer sequences, those feature-length films.
Exactly.
And what about incorporating other data, like audio cues or even emotional tones?
That's another area they're looking into.
So we can tell MarDini to create a video that evokes a specific emotion.
Precisely. It's about moving beyond just visuals and into the realm of emotional storytelling.
This is all so exciting.
It really is an amazing time to be working in AIGC.
This has been a great deep dive, and I'm really excited to see how MarDini continues to evolve.
Me too. It's research like this that gives me hope for the future of AI.
Absolutely. And to our listeners, thanks for joining us.
Thanks for listening.
Keep exploring, keep learning, and keep diving deep.